Hello my dear students. Today the topic is derivation by using the graphical method for various equations of motions. The three equations of motions specifically for class 9 children of CBSE. Generally found children complaining about these derivations where they are unable to catch up the real sequence, and most of them tend to by heart it, and when they bring it on the paper they completely mess up the steps and finally tend to just mug it somehow before the exams and put it in the paper. So I thought of simplifying it, and here today I am there in front of you by a story method which will help you beautifully to understand the derivation without removing anything from the concepts that you have to get in physics. So if you are first time here watching my video, kindly subscribe so that you will get all such videos on your fingertips, and do not forget to press the bell icon. So without more delay, let us get into the video. Dear students, do not skip the video. Start from the first to last without skipping so that you get the concept clearly. Even if you are taking little time, I can assure that at the end you will be the master of these three derivations. So guys, let us go. First things are first. So what is that? That is this graph which is familiar for you, and this is a graph showing the uniform acceleration of a body from a point A to B, and this is a velocity time graph, and there are so many things drawn in the graph. So let us check out what are they. Number one, on the x-axis we have time, and the y-axis we have velocity, and this is the origin, and this is the point from the object is starting, which is the initial velocity. So here is initial velocity, and here is what the final velocity. So initial velocity is not zero. It is not zero, so it is not equal to zero. That point we have to keep seriously while doing the derivation. And then after drawing the graph, at first what we have to write, consider an object, isn't it? Any derivation starts like that. Consider an object moving from a point A to B under uniform acceleration, and let the initial velocity not equal to zero. After writing that, we are supposed to write so many things which is not required to be written here, but you can easily catch it up. What are they? What is OC? OC is the time t, isn't it? That is same as AD, which is same as EB. So you can just write a statement, OC is equal to AD, which is equal to EB, which all are equal to time t. So that is the first thing we are supposed to write. So let me write down that. So OC is equal to AD, which is equal to EB, and all these things are equal to time t. Now let us check the next thing. What is that? OA is equal to CD. Alright, OA and CD are same, so let us write OA is equal to CD, and that's equal to the initial velocity u. And then we have OE, which is equal to CB, OE, which is equal to CB, and that is equal to final velocity v. These are the major values we need before we proceed into the derivations, and whatever it is, you are supposed to write all this. And now, which are the three derivations that you are going to face, right? That heading itself is a confusion for many of the people, and let us start our story right now. Okay, here we can see something written, and this is the Bible to get a clear picture of what is the derivation. So now lend your ears and see things clearly so that you don't miss anything. Here we go. We have three things written here: TV, PT, and VP. These three terms are very familiar for you: TV, PT and VP. So let us see what is the story here. VP is vice principal, PT is physical training, and TV is of course TV. So vice principal is sitting and watching the TV, okay, and in the TV he sees two BD, you know BD. He sees two students smoking BD, all right, maybe some surveillance camera, and then later on he sees the physical training teacher doing some activities with the students, in which some students are kept in the form of a rectangle, some are kept in the form of a triangle, and he is doing something with the students, okay. And then finally VP, and he is sitting in his cabin, a very specially designed, like a trapezium shaped cabin. So this is the first part of the story which you must keep in the brain. So I repeat, it is the VP sitting and watching the TV, in which he sees two students smoking bidi, and then later he sees in the TV the PT teacher training the children and just seeing them standing like in the rectangle or triangle, and then we are just knowing about the shape of the VP's cabin, which is like a trapezium. So this is the first thing. So hope it is clear to you. Now let us go for second. Okay, T and V. Okay, the T and V are very simple. Now let us decipher what is it. Velocity time relation. Okay, so opposite way you read velocity time relation, and then second one position time relation, third one position velocity relation. Hope you got that. Now what is the velocity time relation? What is the formula? That is V equal to U plus AT. Again, are you going to by heart? No. Look, what is the first and last letter? Velocity time, isn't it? Velocity time, velocity time. Look, the first and last letter of your formula, velocity and time. You can see V and T. So V and T, that is the formula for sure for velocity time graph. Hope it is clear to you. Let us go for the second one, that is PT. And in PT, what are you seeing? You're seeing the triangle there. So when you see the triangle, area of a triangle is half into base into height, half. That half should click in your brain. See, the formula having half in it is about the triangle, and triangle is the PT teacher playing with the children. No, so PT is connected with triangle, and the formula half is there in only one formula. Okay, S equal to T plus half AT square, and that clicks. And then comes third one, VP. Okay, as you already know, there are three formulas. Third you can simply find out, but even then if you want to connect it, there is a way. So what is it? So the third formula, VP, is what? 2A is equal to V square minus U square, isn't it? Velocity and position. So to see that, you have to look into the center of this equation. Okay, you can see velocity and position, V as velocity, S as the position. So with these three ways, you can easily connect what is the major derivations that you are going to do, and what is the formula at the end you are going to get derived, and what are the methods you need to derive it. Hold on guys, this BD and this triangle, rectangle and the trapezium I didn't explain. That is on the way, and I'm sure you will rock and roll. So let us get into the first derivation, that is velocity and time, and what is 2BD, and what is the final thing that we are going to achieve, V equal to U plus AT. So here we go. So guys, once you have understood the story perfectly, this what you have to keep in mind while drawing this graph AB. The B should first come to the x-axis and C should be marked there. Then the parallel to x-axis should be D, and upper one should be E. Do not change these letters, otherwise the concept of BD will not be working out. Okay, so now let us get into the derivation number 1. So what we can understand here, I have clearly written everything. Here we go. Derivation number 1, we need to make v equal to u plus at, which we already remember from the letter v and t at the edges. Okay, now let us go velocity time relation. First thing, BC is equal to BD plus DC. What is it now? Look at this line, okay, this line segment BC is a huge line which is actually made up of two pieces, BD and DC. So that is what is written here, BC equal to BD plus DC. Hope it is clear to you. Okay, now from this, imagine I want to take only the length of BD. I am supposed to take out the DC from the total BC, means BC minus DC will be BD. So here we go, BD equal to BC minus DC. Hope you understand me. Okay, so from the total line, if I rub this one, you are going to get BD. That's what it is saying, BD equal to the big line BC minus the rubbed part DC. Now from there, what is BC? Look guys, BC we already wrote, that is the final velocity. And what is DC? Look here, DC same as AO, which is the initial velocity. So bringing them together, BD equal to V minus U. Instead of BC and DC, we put this final velocity and initial velocity formulas, and that is our equation number 1. So guys, this is the first BD I am referring in this story. Okay, there is still one more BD to come. Let us go and hunt for the second BD. What is it? We all know the formula, acceleration is equal to change in velocity by time. So some people get stuck over here after finding the first BD. How will I get to the second BD? Oh, that connection is gone. What is next? Okay, look, here we have found the first part, V and U. See, V and U of the formula you have already taken into this particular point number 1, equation number 1. What is the next letter you have to find in the formula? Okay, you know it is acceleration. Okay, so seeing that letter, suddenly recollect, yes, next what I have to do is acceleration. Okay, acceleration is equal to change in velocity by time. Okay, now we write what is acceleration's formula. Acceleration, as you all know, acceleration in any uniformly accelerated, in this acceleration is equal to the tan theta, which is basically opposite side by adjacent side. So tan theta is opposite side is BD and adjacent side AD. So BD by AD is the formula for acceleration, the tan theta. Hope that is clear to you. BD by AD, which is for acceleration, which is equal to change in velocity. We already told what is the full velocity, final is BC, what is the initial DC. So when you remove DC from BC, we get the remaining BD, which is the change in velocity, means final velocity minus initial velocity. So that change in velocity divided by time. So change in velocity is the segment called BD, which is actually final velocity minus the bottom part initial rubbed. Okay, and that is the BD. So BD by OC. What is OC? Time. See, OC is the time. So we have put BD by AD equal to BD by OC, and now we know BD by AD. Instead of BD by AD, we can use the letter acceleration, and that is the letter we use here. And for BD, let it keep there. OC is the time, as you know it, put the time there. So now cross multiplying, we get BD equal to AT, and that is our second formula. So the first formula is here, BD equal to V minus U, and then you hunt. After finding V and U, hunt for A. Okay, and after going through that and hunting acceleration, you got the second BD formula, BD equal to AT, and there are two formulas with you right now. Now see guys, this first formula is BD, second is also BD. So equation 1 and 2 are same, isn't it? Both are BD. So from equation 1 and 2, we can write V minus U. The first equation, V minus U, is same as AT. So we write V minus U same as AT, V minus U equal to AT, and then we make V as the subject, so we get V equal to U plus AT, and that's it. So to go ahead this, you just need to bring out two BDs and then join them together. That was what the VP was trying to see in the TV. Okay, and that is nothing but the derivation for velocity time relation. Hope it is clear to you guys. And now let us go for the second derivation. Okay, So guys, after that beautiful derivation of the first relation, now we are in the second relation. Let us recollect PT teacher playing with the children, arranging them in the form of a rectangle and a triangle, and thinking about the triangle's area of a triangle is half into base into height, connecting that half here. Okay, is equal to ut plus half at square is the formula what I want to make. And now let us write our heading derivation number 2, s equal to ut plus half at square, position time relation. Okay, PT stands for position time relation. Now let us go. As we told, the area of a graph, that from there we start. Okay, so the area in the particular graph, in that particular velocity time graph, is equal to the distance traveled. So that's very commonly understood thing for you in this chapter. So the area under the graph is the distance traveled. When you look at the graph, the area under the graph is actually the area of a rectangle and the area of a triangle. Okay, so if you add the area of this rectangle and add the area of this triangle together, you get the area under the graph, and that is the distance covered. Okay, so we have to start writing that distance covered is equal to area of the rectangle OADC, see OADC, and area of the triangle ABD. All right, ABD. And after getting that, just we get into that particular concept, bringing the terminologies from there. S equal to breadth into length. Okay, of course, normally we write length into breadth. I have written breadth into length. There is a reason behind it. Anyway, just listen like that. Breadth into length plus half into base into height. Okay, that is area of a rectangle. Now let's go. Area of a rectangle. Breadth in this breadth is OA. Okay, OA, and the length is OC. So that's why OA and OC taken from the graph. Breadth and length, hope it is clear, plus half into base of this triangle is AD and height is BD. So that is half into AD into BD. And after doing that, we write the formula S equal to, now let us put all the values that we need. S equal to, here OA is U. Okay, OA, it's already marked there. Let's go ahead. OA is U and OC is T. Okay, so OA into OC becomes U into T. Now you understood why I wrote breadth into length. If you write length into breadth, you will say T into U. That is also correct, but you have learned it by hearted it, S equal to UT plus half at square for so long. So when UT becomes TU, some of you are confused, what the hell is this? Okay, so anyway, S equal to U into TUT plus half into, what is AD? AD is same as time, so that is the T again, into BD. BD we have written there. From the previous derivation, we already made a formula here, BD equal to AT. So now coming to that, BD equal to AT, we are bringing it over here in this derivation, previously derived. BD is equal to AT. This is the second formula. Now bringing the second formula, this BD, and pasting instead of this BD in the first formula. That is called substituting 2 in the first formula. S equal to UT into half into T into, instead of BD we write AT. Alright, now T into T, AT square. So we get the final formula, S equals UT plus half AT square. So that is the story of the PT, which suddenly brings to your mind the rectangle and the triangle, and you catch up all the things by using that method and beautifully derive the position time relation, which is S equal to UT plus half AT square. Now without delay, let us go for the third derivation. Okay, so guys, the story of the third derivation, the VP is trapezium shaped room, isn't it? Let us go for that. As we know, the VP is sitting in a trapezium shaped room, and then connecting V and P in the middle. V is velocity and P is the position, which is S. Recollecting, yes, the formula is 2a is equal to v square minus u square. Bringing that to your mind and remembering trapezium, let us start the derivation. derivation number 3, 2a is equal to v square minus u square, which is position velocity relation. Okay, so distance is equal to area of the graph like the previous one, and here we write that is the area of the trapezium OABC. Alright, and then this much is clear because trapezium and VP is connected. Now let us go. The formula for finding the area of a trapezium is half into the sum of the parallel sides into the height. Okay, so the distance is equal to half into the parallel sides are BC. I wrote the big parallel side first because I want V plus U instead of U plus V. Okay, so BC and then OA. Alright, so BC plus OA into height. Height is AD. AD is the height of the trapezium. So that is what written there. Now let us pull out all the values and put all the variables there. So half into BC is the final velocity, OA is the initial velocity, so we write V plus U, and then AD is same as OC, which is time. This all we have written already here, right? OC equal to AD, which is time. So we have written that here also, that is time. So V plus U into T. Then some people will get stuck here and like, what is next? Guys, when you stuck on this particular point, what do? This last letter T, okay, he is the one troubling us. Look, we already know the formula, 2a is equal to v square minus u square. V and u are required for us. Here we need it, right? V square minus u square is what we are going to create, so we cannot remove him. So better is to play with the T. Okay, think T. Alright, there comes this connection. This is why I have noted these things in blue for the first derivation was over. So what is it? A equal to v minus u by t. From there we know that v equal to u plus at, so t equal to v minus u by a. That t is equal to v minus u by a is going to help us, so we bring it here. Already derived t equal to v minus u by a, which is equation number 2. Now putting equation number 2 and substituting this v minus u by a instead of this t, we can write the equation like substituting 2 in 1 is equal to half into v plus u into v minus u divided by a. Alright, so this is what we are going to substitute t with this, so we get v plus u into v minus u by a. And now what are we trying to bring it and make it much more perfect? Here we go, s equal to v plus u into v minus u divided by 2a on the denominator, and then s equal to, okay, v plus u into v minus u is equal to v square minus u square, as you know it, v square minus u square by 2a, then cross multiply and you get 2a is equal to v square minus u square. So dear students, now whenever you get these derivations, you have to just relax, draw the graph, write all the things, consider blah blah blah, whatever is required at the start, and then think which is the derivation asked. Go. If it is velocity time, TV, position time, PT, and then third one is velocity or position velocity, VP, PV, right, whatever it is. Now once you hear that particular heading or see the heading, accordingly you can connect the steps. So let us recollect so quickly. If it is TV, means velocity and time relation, yes, you need to find two formulas for BD. One is BD equal to AT and one is BD equal to V minus U. From there you bring together and you got the first derivation done. If you are having the derivation position and time PT, suddenly you remember the PT teacher playing in the rectangular and triangular shapes, and then you bring the area of rectangle equal to breadth into length and the triangle to half into base into height, and then substitute all the values, you go get s equal to ut plus half at square. On that one particular point you remember is the at square, the at you have to bring from BD equal to at, which is the previous one. And then third one, when you get this particular derivation, position velocity P and V, put it opposite VP. Oh, VP is sitting in the, okay, that room, trapezium. Fine, area under the graph, that is the distance. Trapezium's area is equal to, so you just go ahead and write half into the sum of the parallel sides into the height, and then put all the values. Meanwhile, when you come and get stuck at T, think, okay, I should not change anything, V plus U, rather I can play with the T. Okay, let me change it. Okay, yes, I have to connect the T with the previous equation which we made at the first. From there we bring t equal to v minus u by a, substitute it, and at the end by cross multiplying you rearrange and get the equation 2a is equal to b square minus u square. So hope this helped you, and if you liked, kindly give your comments at the bottom. If you would like to get such more videos with so many stories and tricks that helps you to decipher out the tough stuffs in your book, kindly comment below so that I could make ample steps related to that and bring for you such new videos. So guys, that's only for today, and let us meet in the next video. Till then, bye.